So on the agenda for today, we are going to go over assignment 1. I was going to talk about comments, warnings, and errors. That content was from the textbook. I don't know if I'll cover it today or not. Talk about expressions, compound operators, some rules associated with division and division operators, and then talk about assignment 2. So in assignment 1, I guess I don't have that either, so it's not on there. Give me 1 second here. Let me try and get this. Nope, it's fully down. Okay, so in assignment 1, recall we were going to declare 3 characters, 3 integers, and 3 floating point numbers. Print one of each on one line 3 times, and then print all 3 of each on one line 3 times. Reassign their values, and go again. So I'm just going to go through. I'm going to write that assignment. Feel free to stop me at any time if you have any questions about what I'm doing. Otherwise, here we go. So for my 3 integers, I'm just going to say int a, int aa, int aaa. For my 3 floating point numbers, I'll say double b, double bb, double bb. And then for my character, I'll say char c, char ccc, and then ccc. So remember that we can assign values when we are declaring them for the first time. So I can say 10, 15, 20, like that. I can continue on. I'll just assign all these values, or assign these all values as well. So say 1.1, and then we will do A, B, and C. So I don't have the assignment text up right now. It was one of these 2 ways, but I'll print it this way first. So we say printf, and then on our format string we print the integer first, the floating point number second, character third, and then a new line. So remember that the a is going to replace that %i, or the value stored in a, I should say, is going to replace the %i. The value stored in b will replace the %f, and the value stored in c will replace that %c. So let's just go ahead and, I'll go ahead, I guess, necessarily. But I will go ahead and compile and run this, just so we can see where we're starting off. And we can see that printed 10, 1.1, and a. So we could also, remember, control the precision of our floating point number being printed. We could say 0.2f. Close that out. And we can see that would print 2 decimals. So going on, you need to copy this line, do it 2 more times, change your variables so they're the next type. So AA, BB, CC, and AA, BBB, and CCC. And that would print all of our variables. So the second component of the first half is printing all of the variables of the same type on their own line. So to do that, we need to say %i, 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 and then a new line again. And say AAA, AAA. We'll open this up again. I'll show you that that's going to work. It's going to print 10, 15, 20. I'm just going to copy that line down, change all of these to print floating point. Just got to change the format identifier to match the variable. And then do the character one as well. Change that to %c to match the character. and compile that and run it. So that will complete the first half. So after we've done that part, after we printed them one on each line and all on their own line, we also need to go back through and reassign all the variables. Now, in order to do that, we will just say the variable name from above. So let's say a equals 100, AA equals 200, AA equals 300. That will reassign all of our integers. Then we do the same for the decimal numbers. So I'll just add some random numbers in here. And then finally, we'll reassign the characters. And then after we've reassigned everything, we have to call our printfs again. So we take all that and then type it down below our reassignments. So recompile the program, run it again, and we can see that is our output. So this is the first half, this is our first printfs, and this is our second half and our second, well, this is our second half and our second printfs. So in order to, this wasn't required, but in order to match my output exactly, again, it wasn't required, but you should have, or it would have been nice if you would have put 2 new lines instead of just the one. So that would have printed a space between the 2 different sections. So that is assignment 1. Any questions about assignment 1? All right then. Let me see if I had anything more. So yeah, I should have that graded by about next Tuesday. So I'll post feedback on D2L if there is any need. Let's see if this is up yet. Okay, so the next component I was going to talk about was comments, warnings, and errors. So this was something from your reading that I want to talk about. So it should have been like, let's see if it loads. So 1.5 was the section that we were on. So just remember that using comments, so a single line comment does start with these 2 forward slashes, and a multi-line comment starts with a forward slash and then an asterisk, and ends with an asterisk and a forward slash. So just going to go look at that. So this is a single line comment, so anything I type here will be ignored by the compiler after the forward slash. So if I go ahead and compile this program, there won't be any errors, no output, no nothing, because that single line was going to be ignored. And then for multi-line comments, what we can do is we can have a slash and then a star, and then finish off our multi-line comment by saying star and then slash. So anything inside here, let's say I have some commands or something, all of that is going to be ignored as well. So I'm recompiling that, running it again. We can see that there's nothing outputted because there are no actual statements that are going to be run. So I guess I can go back over here. Let's say we wanted to not reassign any of our variables. Real quick, what we could do is we could put a block comment around that entire, around all of these reassignment statements, and that would stop them from being processed when we're compiling our code. So go back in here, recompile it, run it. You can see that none of our variables changed because that block comment means that we're going to ignore all of the statements inside of it. Again, line comment comments out a single line, block comment comments out an entire block. Like that. Okay. So that was all there was for comments. I feel like there was something else I wanted to talk about here. Nope. Okay, so I will continue on and talk about errors and warnings again. Now we talked about this very briefly, about what some of these different things would mean, but I'm going to go through and just show you this again. So when we have something like this, when we're missing a semicolon on a line, and we compile our program, it's going to say error expected semicolon before C. So this line is actually the next line, and basically what this error is saying is that it expected a semicolon before it sees the next line. So we open up our program. We can see that it tells us where exactly this error is occurring. So this is on line 10, column 2. So starting from the top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I started counting it the wrong number, but this is 10 right here. And then column 2, since I'm using a tab character for my indentation, so we go 1, 2, and it expects a semicolon before there. So again, if it says expect semicolon, you can pretty much assume that it's you're missing a semicolon. So you replace that and it worked again. So remember, if it says something like this, let's say we forget to put our ampersands on our scanf statement. Let's go back through, compile that. You can see it says warning format %i expects argument of type int star. What's actually happening here doesn't really matter that much, but you know exactly where that error is occurring, and you know you essentially know why, because it says on line 8 you didn't make a mistake. So going back over there from the top, 1, 2, 3, 4, 5, 6, 7. Again, I counted wrong again, but you can see that it will warn you if you do mess up something. So let's look at a slightly more complicated one. Let's say we forget our closing brace at the very end of our main function. So we can go back, compile it again, and it will say error expected declaration or statement at end of input. So this one's a little bit more tricky. The problem is the compiler doesn't really know where we want to end if we don't have a closing bracket here. There's not really much it can do to help us debug this problem, but that's another error that we could encounter, would be missing a closing bracket. So another one we could encounter, let's say we leave off our parenthesis here. So this one is actually pretty easy, because we just left off a parenthesis. If we would have left off the parenthesis and the semicolon, it would have gotten tricky. But here it just says error expecting parenthesis before semicolon. So that one's pretty simple. It shows you right in the code where you need to add the parenthesis. It's just important to read the error messages. But let's say we left off the semicolon too. That error message should get a little bit more difficult. So the problem here is we see that there isn't actually any line, or the line that it's telling us where the error occurred isn't actually being very specific. So this would be what you would expect to receive if you left off the parenthesis and the semicolon. So again, not much help, but it does let us know that we are making an error. So that's all I think I wanted to cover with errors and all of that stuff. Any other questions about errors and warnings and stuff like that? Okay. So on to expression, or talking more about assignments and expression. So remember that the basic formula for assigning a value to a variable is to say the variable name on the left, and then say an expression on the right. And I forgot to put a semicolon on here. So specifically what an expression is one or more literal So a literal number, these are examples of literals down right here. A variable, so a variable name that we declared before, or an operator. So we can specify plus, minus, divide, multiply, anything like that. So I just want to go ahead and show you that, again, that we can specify a expression anywhere a variable is expected. Variable or literal, I should say. So let's say we have int a and we set it equal to 10. Let's also do int b and set it equal to 20. So we can take, let's say we had a, we can set it equal to 10 specifically. We can set it equal to b, or we can set it equal to like 10 plus 10 plus 10, and so on and so forth, chaining any number of variables, literals, and operators together. So we can say, let's say a plus 10, it's valid, b plus 10, a plus b, again chaining any number of variables, literals, and operators together. So all that matters is that on the left side is one single variable, and on the right side is something. Basically, you really can't go wrong putting anything on the right side. Just remember that when we're processing this, this expression, we're going to take the value that's stored in A and add it to the value that's stored in B and store it into A. So just to make this a little more clear, we could have a third variable, which we are actually going to store our computed value in this expression into. Just remember, you can, again, can't stress this enough, but you can put any number of variables, literals, and just chain them with operators. And you can, of course, use different operators, so that will add 10 and 20 that are stored in B and or A and B. So you'll get to 30, and then you subtract 10, which will leave you with a result of 20. So this expression right here will evaluate to 20, and we will store the result from that expression into C. So just a couple more examples of expressions, and then so here's another thing we can talk about. So when we're saying printf, it's not specifically expecting a variable or a literal, it's actually expecting an expression of some sorts. So when we're saying printf, let's say we wanted to just print out a single integer followed by a new line. Let's say printf a, let's compile that really quick. Ignore the unused variable warnings. We can see that prints 10. So let's do this a couple different ways. So that's with a single variable, that's with a literal, and then finally we can do this with an expression as well. So we could do 5 plus 5 so that works. So even more complicated, not necessarily complicated expressions, but let's say we did something like, 5 times 2 would work too. We could do 100 minus 90. Any expression that you could, or an expression is valid to put in here where we are expecting a variable or a literal. So just kind of want to go over that again. So hopefully that makes some sense. Those are all valid. So any other questions about different expressions that we can write or assignments or anything like that? All right. So next on the list is compound operators. So let's say we wanted to add a value to 10. So just with our basic operators that we've learned up until this point, we would have to say a equals a plus 10. So that will take the value stored in a, add 10, and store it back in a. So we can actually use something called compound operators to remove the redundant a. So this line right here shows what it would look like with a compound operator. So we would say a plus equals 10. So that's read the exact same. So these two are basically read the exact same. And they're equivalent. So Both are take the value stored in A, add 10, and store the result in A. So we can do the same with any other arithmetic operator. So we can say minus equals, times equals, or divides equals. So I'm just going to go through, do a real quick example. So A plus B equals 10. Print that out real quick. And I'll just copy all these down. So we'll change this to be subtract 10. And that changes to multiply by 10. Change that to divide by 10. And format it a little bit nicer. And so we can see that all of those expressions are valid. But it's good to remember that compound operators are a way to remove that redundant variable. So again, this is equivalent. These two lines are equivalent. Let's go through and do them all, I guess. So all of those lines are equivalent. So that is compound operators. Any questions about that? All right. So the final topic that I had for today was some rules about division. So division in C is actually kind of complicated. So let's say we have two integers. So we have int a equals 20. Let's say we have int b equals 10. So we're going to print the result of dividing those two integers. So let's divide a by 10. So it's going to be 20 divided by 10. Compile that, run it. So we get a result of 2. So let's change those numbers a little bit. Let's change this b to be a 9. And then we're going to run it again. So we can see that also resulted in 2. But from our perspective, dividing 10 by 9 or 20 by 9 isn't 2. It's more like 2.2 or something like that. So the first rule, so when we divide two integers, the result will be truncated. So whenever I say truncated, I mean unconditionally rounded down to the next whole number. It doesn't matter if it's 2.9 or 2.1, it's always going to be rounded down all the way to 2 if we are dividing two integers. So even if, let's say we try and have a result variable, we'll just call it res, or we'll call it a double res, and we do our calculation. We print that out. We can see that even though the place we're storing that result in, the result of that expression, has the capacity to hold a decimal component, it's not actually going to be a decimal component. So regardless of where we're storing the result of our two integers, if we're just doing it like this, just dividing two integers, it will always be stored truncated. So let's do this the other way around. Let's change this to be double. Change that to be double. And change our result to be int. And we will print out I. Or print out res, I should say. So we take that, compile it again, run it, and we can see that the result is 2. So our second rule is that if we store the result of two floating point numbers, or the double types, as we talked about before, the result will also be truncated. So even though the two numbers we're dividing are decimal numbers, If we store it inside of an integer, it's again going to truncate the remaining decimal places. So we talked about this one too. This is associated with that first rule. So if we store the result of integer division inside a double, it will be truncated. So the way we get around this is by doing something called casting. So I'll change everything back around the way it was before. So remember, this was our problem. It was we were storing the result as a decimal number, but we can't do that because both of our divisors are integers. In order to get around that, we need to cast one of them to double. So in front of one of the variables or literals, we need to say double. So what that will do is it will convert one of these numbers to be a decimal number. And so long as one of our numbers inside of our expression is a decimal number, the result will be stored, or the result of this expression will be a decimal number. So we can see now the result is correctly stored. So I have this example, same exact example inside of the PowerPoint. So this is incorrect. This might look right. It feels right when you're writing it the first time, but it will give you unexpected results because you are going to drop the decimal component on integer division like this. So just remember, you need to say double on one side. And my example is a little bit wrong here, actually. The variables. So I'm just going to go through, do a couple more examples. So let's say we had this. Let's say instead of saying this b here, we said 9. So we can see that's still going to give us that 2 truncated. So there's two ways we can get around this when we're doing it with literal numbers. We could again say double in front of one of our variables. That would work. Or what we could actually do, which is a little bit more concise, I think, is we could say 9.0. So again, remember what I said was all we have to do is make sure that one of our things inside here is a decimal, and the result will be a decimal. So going back, we can see that now produces the correct output. So this is one of the things that's really tricky about C, and it's a concept that gets a lot of beginners off, or catches them off guard. You would really expect that when you're dividing two integers, that by default they would be a decimal number result, but that's just not the case. So we have to do a little bit to work around some of the things in C. So let me think here to have anything more about that. Nope. So any questions about division or anything like that? Yep. So here's the thing about multiplication. So you multiply two whole numbers together, you're always going to get a whole number. If let's say you're going to do this, that's always going to be a whole number result. In order to get a decimal result, you have to have a decimal component. So if if part of this was a decimal, let's say I guess that's going to actually end up in a whole number. Let's change that to 20.8. Like 20.7, that's a better number. Oh, I suppose I'm using 10, so if I'm multiplying it by 10, then I'm obviously going to get, or if I'm multiplying it by, I don't know what I'm doing. So again, the reason this is a problem when we're dividing is we can divide two whole numbers and get a decimal result. but we can't multiply two whole numbers and get a decimal result. Let's do 0.1. That's a good number. Well, actually, it's going to give us 2. It should. So again, I picked another number that's not going to work. Okay, so I'll just pick a really, really, really small number, and we'll actually get this. That's nuts. We'll pick a number like that, and that should definitely give us a decimal result. So that gives us a decimal result, and we can see that that's correct, or approximately correct. I don't know if does that kind of make sense? Does that, or were you hoping for something else? Yeah, it's just division's kind of the edge case. It's hard to deal with sometimes. So that's that. Any other questions about that? Okay. So the final thing I was going to talk about, well, actually, so one of the things I did post on D2L earlier, I'll talk about this too. So you should read the remainder of Chapter 1 by Thursday. You should also complete any challenge activities that you might have gone over. So when I assign reading, generally speaking, you won't have to do the challenge activities the first time you read through it. You only need to do the participation activities by the time that I say to do it. So like for the rest of these reading assignments, all I wanted you to do was the participation activities in the text. But when this time comes around and we're getting to the end of Chapter 1, I do want you to go back through and complete all the challenge activities. So do complete all those by Thursday. If you've looked at the grade section, I did update a couple things. So I added what the point values will be for all the reading assignments. I should have graded all of the in-class assignments that we've done, so you'll just get a single point for those assignments, and I added a category for assignment 1. So again, you should see assignment 1 graded soon, but you should also expect for our first quiz on Thursday, so that will cover the material from Chapter 1 and other material that we've covered in class. So you should be aware that that test will be closed book, closed notes, closed everything. So if you are feeling unsure about the material that we have covered so far, definitely take some time and review it. So any questions about those items? All right. So the final thing I want to talk about today, you might have seen it already on D2L, was assignment 2. So assignment 2 should be pretty simple if you've been following along in class. So for assignment 3, I want you to create a program which calculates sales tax. So you will prompt the user for the subtotal and the tax rate for an order, then calculate and print the total. So 2 examples down below here. So this one just shows the output. So these should be generated by printf, and right here is what the user types in. So they type in 10 for their subtotal. They type in 0.07, and then you print out the total. So I didn't say it in here specifically. I'll probably edit it in a moment here or so. But I do want you to print the $sign, that's important, and I want you to print the decimal to 2 places, which is also important to me. So I've created a sample program which is located at dist assignment 2. So when you are on dev.dist-unix, what you can do when you're at your prompt here, you can just say /dist/assignment2, and that will open up my program that I wrote, and it will run it. So you can say, let's do the exact same example that I did here for the assignment. So I would say the subtotal is 10, tax rate is 0.07, and it will output the total of the order. So this assignment, again, should be pretty simple if you've been following along in class. What I would do is I would declare 3 variables. I'd read in this value into 1, this value into the 2nd, compute the tax rate, store it into the 3rd, and print it out. So a couple things that you might not catch on to right away that are important. I don't remember. I hopefully did this. I don't remember if I did this. So you do need to allow decimal numbers when you're typing in subtotal. So we can see that that equates to 10.81, but that doesn't feel right to me. I think I probably did something wrong with when I was writing the example, but I'll go back and I'll change it. So just keep in mind that you do need to accept decimal numbers for the subtotal, the tax rate, and then finally print it off as a decimal. So any other questions about, I guess, any of the Chapter 1 material, anything we covered in class today, or anything else for that matter? They'll most of them will be fill in the blank, I believe. Yeah, I think most of them will be fill in the blank. I will, like, for example, some questions might ask, given a program source code, what will this program output? So I might have something as simple as this program that we talked about here. Well, this is actually kind of a complex example, but like this, what will this program output? And then there'd be a box for you to put your result into. There's also, looking at your readings that you've been doing, there has been lots of terms like this, like bug, compile time error, things like that. I'll try and pick some of the more important ones, and those will be questions on the test. So something like enabling the printing of output, you should know how to do that. You should know that when you need to use printf, you need to say include stdio.h. You should know what a new line looks like this is a new line, and so on and so forth. And you should know that between double quotes is strings, and so on and so forth, things like that that you've covered in your reading. So I think that's all I have for you today, no in-class assignment. So if you have any questions, stick around. Otherwise, you are free to go. So right now, I just remember that I don't have assignment 2 on submit, but I will add that momentarily. So just keep in mind that that will be due Sunday at midnight. So that's all I have for you. Well, there's easy ways and there's hard ways.
I don't think he messed up. That's the.
Does it work?
Yeah.
Okay, I'm just not good at math, that's all. What are we on, day 5 or day 6?